Now I want to go through a couple of examples of how to use StatCrunch in the homework. So what I'm going to do is go to the study plan and then view all the chapters and go to chapter 20 where we're looking at independent samples, T inferences. And then what I did was just picked out a few problems here. So let's go with question 67 to start. And here it says an educator randomly assigns students to a program of which some use a new reading activities and others use a traditional teaching method. And then at the end, both groups take a reading comprehension exam. Their scores are shown in the stem and leaf plot, which we really didn't talk about stem and leaf, but we're going to open the data in StatCrunch in just a minute. Do the results suggest the new activities are better? In other words, would students who are taught using the new method have a larger mean score? Test an appropriate hypothesis and test your conclusion. Okay, so let's say that new activities are sample 1, control group are the ones who use the traditional method or sample 2. Then if the new method works better, then the new method should have a larger mean. So when you take the difference, a larger number minus a smaller number would be positive. Okay, so we can check our answer there. And then compute the t statistic, right, and round to 3 digits. Okay, so this is where I'm going to go to StatCrunch. I'm going to open in StatCrunch. So I've got the new and then the control group. So what I want to do is go to stat, t-stats, to sample, because I've got 2 groups. And this time I'm going to do with data, because I don't have the summary information like means and standard deviations and sample sizes, but I've got the individual measurements. So the first group, I'm going to put the new activities. The second group is going to be the control. I'm not going to pull the variances here. I'm testing the null, that the difference in the 2 population means is 0 versus the difference, and remember we said it was positive. Click compute, and then there is my t-score, 1.931. What about the p-value? The p-value for that one-sided test is 0.032. And then what about the conclusion? Well, is 0.032 less than 0.05? Yes. So I know I'm going to reject the null hypothesis. So I can eliminate A and B. So it's either got to be C or D. There is sufficient evidence that the new activities are better. There is not sufficient evidence that the new activities are better. Well, if I'm rejecting the null, I am saying that the new activities are better. So answer C is going to be correct. Now let's move on to another question. Close out of there. I'll go ahead and leave StatCrunch up, but this time I'm going to do question 83. So it says a golf manufacturer used a robot to hit balls off their tee and off of a competitor's tee using the same club. So the idea is you have a robot hitting, that's going to be a consistent force striking the ball, so hopefully the only difference is going to be whether it's your tee or the competitor's tee. Assume 103 balls were hit off of each tee. The data are suitable for inference. Is there evidence the balls hit off the manufacturer's tee have a higher initial velocity? So does it come off the tee faster right when it's struck? Can we prove that? Well, we're trying to say the manufacturer minus competitor would be positive in that case. So that would be answer B there. Compute the test statistic. Now this time I've got the summary information. So when I go into StatCrunch, pull it back up. Oops. Go ahead and close that. I'm going to go to stat, t-stats, to sample, but I'm going to do with summary this time. And what I've got to do is enter those summary values. Okay, so if I'm doing manufacturer first, so that's the second row in the table, so you got to be careful there. 231.87. The sample standard deviation is 2.58, and the sample size, remember they said, assume 103 balls were hit off each tee. And then in the second sample, I would have the 229.8, 2.01 for the standard deviation, and then 103 for the sample size. Then I want to do a test where manufacturer minus competitor is positive, and then click compute. So that's going to give me my t-score and p-value. So round to 3 decimal places, so 6.423. Okay, so what is this doing? So let's see what it said. Manufacturer minus competitor. .423. Okay, so let's see if they're looking for it to be negative instead. So I'm just going to put a negative sign in and guess at what they may be doing here. No, that's not it either. Okay, one other thing I can try. I can go back. Oh, make sure the pool variances button is not clicked. Although in this case, it's not going to change the outcome. So what is going on in this case? Did I enter the values right? Is that a difference of, that is a difference of 2.07. Let me go back and make sure I entered the numbers correctly. 2.58, 231.87, 103, 229.8, 2.01, 103. Oh, I entered the wrong information. They want ball velocity. Now I see the problem. Okay, I was doing distance in yards instead of ball velocity.